I'm Harshvardhan. My data analysis on the sales of Walmart. So my goal is to perform regression ML models on the data to find the model that bestly predicts the weekly sales of Walmart. So the first step is to import libraries. So you could see some of the libraries are imported for data pre-processing, data visualization, modeling, and evaluation purposes. So you can see data is loaded here, and within the data you could see the different data types here. The store and the holiday flag has int type, and date has object type, and the rest have float type. So there is no null values in the data, as you could see in this step, and the describe function describes the statistical distribution of the data. So our target feature is weekly sales. Let's split the data into input and output. So the output consists of the weekly sales data, and the rest comes under the input data. So let's split again the data into train and test data for the future purposes. So you could see the test, could see the train data that has no null values as we know before, and let's check if there is any blank and null values here, and you could see there is no null values, and checking whether the duplicates exist in the data. So there is no duplicates in the data. So let's perform some future engineering here. Let's convert the data object into day, month, and year columns. So let's first convert the object into the date time object, and let's convert into date, month, year by simply extracting it from date time. So let's drop the date column here and check if any constants exist here, and also check if any quasi constants exist here. I could see there is no quasi constants here as well. And and the next thing is here, you could see the visualization here that shows the count of holidays and non-holiday weeks. So basically the non-holiday weeks are more compared to the holiday weeks here. And using the cost tab, you could see that per every year from 2010 to 2012, you could see how the holiday flag is distributed here. The holiday flag in 2010 has 123, which is lower when compared to the non-holiday weeks that has 1368 in 2010. So similarly, the pivot table simply explains the consumer price index per each year, that is from 2010 to 2012. So the 2012 has a leading price consumer price index here, which is 175. So this pie chart shows the overall yearly sales for each year. That is 2010 has 33%, and there is some slight decrease here in 2011, that is 30%, and drastic increase to 2012, which is 36% here. So this correlation heat map shows the correlation between the futures and the futures in the target variable. So you could see the fuel price in the year as highly correlated. That shows the multicollinearity, simply applicable for the holiday flag and month as well. So let's perform the distribution on the data. You could see the histogram distribution here on the continuous data, and similarly the box plot distribution here as well. And let's perform the same feature engineering on the test data as well. You could see here the data is dropped and the data is being converted into year, month, and day before it's dropped. So we could see the feature selection is performed here using the F regression that shows the, based on the correlation score, we have dropped some of the features here. You could see the day, year, and fuel price have been dropped here. Let's simply do for the test data as well. So let's use some of the models that is applicable for the data, and let's see which model is perform better on this data. So the linear regression, descent regressor, and random forest regression have been used on this data. Let's perform each and see which is performing better. So the linear regression is fitting the model to the data, and the model is tested and model is evaluated using some of the metrics like R square, MSE, MAE, and RMSE. So MSE is the mean square error, and MAE is mean absolute error, and RM is the square root of mean square error. So you could see, so when comparing to all of these models, you could see the random forest model performs better with a better R square, and the lower MSE, MAE, which are the error metrics. So in conclusion, you could clearly say that random forest model has performed best on the sales data based on the error metrics and the R to R square value.